Hi, my name is Andrew Zeller. I'm the Director of Construction Technology here at RW LaPine. I've been here for 4.5 years, started the department, and now we have a number of individuals that, part of the department, we're trying to actively use BIM on as many projects as possible. We primarily focus in industrial, commercial, pharmaceutical, approximately $100 million a year. With that being said, there's nothing too big or too small. We do everything from residential through large code compliant projects, code-based projects, any material, copper, carbon, stainless steel, obviously PVC, everything from underground through 150 feet in the air. So Gun Lake Casino in Wayland, Michigan. We focused on the piping and plumbing and HVAC. Obviously the HVAC was for the entire project. The piping, plumbing, DWV, domestic, process piping, hydronics, that was on the Aquadome casino expansion side of things. We actually worked with another large mechanical contractor in the area to handle the rest of the project as well. That project, I'm going to say, was in the neighborhood of approximately $25 to $30 million. So the project overall was managed by the GC. They utilized Project Site for the entire project. Internally with RW LaPine, we utilize several RTS 873s, obviously with all the little accoutrements that come along with that. We also use our X7 scanner for quite a few different operations. We actually provided the BIM and the coordination for several other contractors on the project as well. So going through and running everything from the initial prefab all the way through final QA, QC, and as-built modeling. Current workflow with the 873s is we will go through on the computer, obviously run through all of our modeling, coordination. We'll run it through Trimble Connect and Siskiyou. We will then take the field points, export those out to whether it be Connect or through Teams, whatever works for that specific project. Import them into the 873. Our field crews will then go out and lay out. Not only will they stake the points that we've given them, but they will also create their own as-built locations if for whatever reason something needs to change in the field. From there, we'll take that information from the 873s, save it back to the cloud. Then back in the office, we're able to take that cloud information, import that back into our model, and we can verify all of our points back in Revit and Navisworks. Scanning is very similar in the fact we do whatever we can back in the office. Obviously, scanning is a little bit different in the fact that you're actually collecting data rather than trying to tell the equipment where to lay out. So we will go out, scan, bring it back in through RealWorks, do all of our post-processing, break it down, clean up the scans, export that out typically to an RCS, RCP format that then we can bring into Revit and Navisworks, and then do whatever we need to, whether it be create as-built documentation, or we will actually send that out for prefab. Say we're trying to coordinate with structural steel. By using that point cloud, we know exactly where everything is at extremely accurately, and then from there we can basically validate all of our prefabrication. So our typical workflow is going to be obviously coordinate and sign off with Revit. We will then go through and convert all of our ductwork through Siskiyou. Once we have everything converted, numbered, ready for prefab, we then send it out to our shop, and we actually use Fab Shop in our shop for all of our ductwork, whether it be on the coil line here, on our plasma tables. From there, obviously with Fab Shop, creates our stickers for us. We can slap those on all our fittings, and it's literally like putting a Lego set together out in the shop or out in the field. So as far as the RTSs and the layouts, we try to lay out as much as we can. I mean, when you really think about it, if you can lay it out with a tape measure, you can lay it out with an RTS. The question is whether or not it makes sense. My entire job is based solely on utilizing technology and increasing efficiency, but no matter what, every job will still have room for a piece of paper, a pencil, and a tape measure. So with that being said, we have to look at it on a situational basis, but we utilize the RTS 873s as much as possible on every project. Everything from underground, where those machines are running. If our guys are in the dirt, the machines are operating. From there, we're also laying out points, whether it be on the ground and shoot a PLS up to get that onto the deck, or we're shooting directly to the deck. 873 can handle that obviously just as well. And yeah, we use it for actual layout as well as validation and verification of our systems. On the scanning side of things, it's again kind of situationally dependent, but a lot of times we're trying to go out and either validate our design to make sure that our guys installed things in the correct location, or other contractors installed things in their correct location. A lot of times that's going to be for structural, whether it be steel or concrete, just to make sure that our prefabrication assemblies can operate and actually be installed back in the shop or back in the field. Yeah, so on this project was our first one in-house on a large scale that we actually used Bangits. We had actually gone through, coordinated all of our hangers on, say, first floor. When they go to pour the second floor slab, we go through and utilize the RTS to give us our different points on the deck. We then install the Bangits, and then they go ahead and concrete over all that. By doing so, it minimizes and or eliminates the need to have to go up onto a onto a scissor lift, drill, use whether it be epoxy anchors or wedge anchors, whatever the project requires. Obviously minimizing the amount of silica is situations that we have to deal with. Obviously the whole silica ruling with OSHA. And then from there, you know, that was probably the biggest new thing that we've done. We noticed a big increase on that. On this particular project, we said, yep, we're going to do it on everything that I believe was 3/8 and 1/2 inch hanger. And we have guys who are saying they don't care what size hanger it is, they want to use Bangits as much as possible on these projects. It was just such a labor savings, both upfront and long term, in the fact of they don't have to worry about the vacuums, they don't have to worry about holding the SDS drill over their head, they don't have to worry about, you know, the epoxy dripping down onto the anchor rods. So definitely a big savings there. But yeah, that was probably the first new thing that we did on this one. On this project, we had 6 permanently installed prisms. Being up on the 18th floor, we really didn't want to have to set up the RTS, come down the elevator, walk out to all these different site control points, and then go back up to the RTS in order to actually start laying out. By using the site control prisms, what we were able to do is set up the RTS on the 18th floor. We shot one 1,700 feet away in a far corner of the site, locked on. That was a known point that we actually had in the model. And from there, you know, that was probably the furthest one. We had others, I'm gonna say 1,200, 1,300 feet away, all the way down to 600 feet. And by not having to travel, if we had to travel that distance, it would have taken us a half hour absolute minimum to do a setup every day. Honestly, there are probably days where it would have taken us closer to an hour just because of the weather. With that being said, by utilizing these site prisms, we were able to get set up within 5 minutes. It usually took us longer to wait for the RTS to fire up than it did to actually shoot these prisms. The biggest benefit that we've seen is definitely going to be labor savings, whether it be through the RTS, using the X7, through the prefab process, obviously, you know, using Siskiyou to actually be able to spit stuff out to the shop a lot more easily, a lot quicker. It's extremely difficult to put an accurate number on how much we've seen. Conservatively, though, we've seen anywhere from 25 to 30% labor savings just on underground, just by utilizing the RTS. That's not including any of the prefabrication or the coordination aspect of it, but just the fact that our guys do not have to set stakes and pull strings and pull out the tape measure and verify things. You know, they can put their prism in the dirt, say, yep, dig here. Trench comes in, or the backhoe comes in, actually digs that trench. They set their pipe pretty close. As they're backfilling, they're actually holding that prism on top of that riser up into the dirt, and they're backfilling. And as they're backfilling, they can verify that that pipe is not moving. You know, that alone is just absolutely huge. Not having to trip over things. It's obviously, you know, hazards when you're working out in the dirt, but the labor savings alone has paid for this equipment time and time again. I'm going to say 25 to 30% labor savings on the underground just by utilizing the RTS. If I had to guess, we're probably neighborhood of 30,000 points overall that we've laid out across the entire project, whether that be for underground or shooting hanger points, bangets, floor and wall penetrations. This project, we have obviously our pipe crew and our sheet metal crew. They each have their own, and we've kind of just left it up to them to say, hey, use it when it makes sense to you guys. Here's all the information that we have in the model. We're obviously building by the model, so we want you guys to try and utilize that as much as possible. And so they kind of use it where they see it being appropriate. And I'll tell you, there's not a day that goes by that these guys don't have that thing pulled out, because it's just so much quicker and easier for them to lay out that way and verify things that way rather than trying to pull out the tape measure. So yeah, again, it's very difficult to try and truly compare apples to apples on any particular project. But with that being said, yeah, there's definitely been a labor savings because of all the Trimble equipment we've used. So unique to this project is the Aquadome. It's not a square, it's not a rectangle, it's not even a consistent curve. It is literally an egg shape. So no matter where you look or what angle you try to point to, nothing is consistent on this project when it comes to this particular area. And so because of that, trying to lay out in a typical project, yeah, you can pull strings very easily, relatively easily and quickly. This one in particular, though, we have angles that are down to hundredths of a degree. And so because of that, the RTS really, I don't know how we would have done it without this. Between the prefabrication and being able to use the RTS, just the labor savings alone is immense. Things that went very well, obviously we're going to do again. Using the sight prisms, utilizing the RTS for everything we possibly can, doing the prefab. Of course, all those things, because we saw the savings, we know we're going to be doing them again. Things that we probably wouldn't do again moving forward, not because it didn't necessarily work, but because we didn't see the ROI that we expected. I honestly couldn't tell you. That's one thing about RWL, is we're very good at analyzing things before we go and do them, whether good, bad, or indifferent. It's just kind of the way the company works. But overall, I honestly can't think of a thing that we wouldn't do with Trimble moving forward that we did on this project. There were just so many benefits, and it's definitely helped out the project.